Welcome, everyone. I'm very pleased to be here with an expert panel for the Fraction Foundation's MOOC for Educators. And we're very fortunate to have three of the nation's leaders on elementary math education, and they certainly all know lots about the research on teaching and learning fractions and good practices, all from the University of Missouri. And I think we'll begin by asking each of you to introduce yourselves and just say a little bit to share a little bit about your background and perhaps your research interests. So, Bob, would you like to start?
Sure, I'd be happy to. I'm Barbara Doherty. I'm a research professor at the University of Missouri, and my research interest in fractions has been to look at ways in which fractions are developed through quantitative reasoning, thinking about the importance of unit and how unit impacts student understanding not only of whole numbers, but how it carries over into fraction research. So that's my research backgrounds.
Great, thank you. John?
Yeah, I'm John Lannon. I've done a considerable amount of work with elementary pre-service teachers and their understandings of fractions, and I worked with Catherine on a book for the National Council of Teachers of Mathematics that involves the development of fraction understanding in grades 3 through 5.
And Catherine, a little bit about your background?
My name is Catherine Cheval, and I'm a researcher in mathematics education at the University of Missouri. And my previous life, I was an elementary teacher, a third grade teacher, and a sixth grade math teacher. My research interests are all at the elementary level, effective teaching of mathematics, helping pre-service and practicing teachers learn how to do that well. But I'm also really passionate about children that are underrepresented in mathematics in this country, especially English language learners, children from diverse backgrounds, and helping teachers learn how to teach them well.
Great. Well, thank you all for joining us and being able to share your extensive knowledge. I'm sure all of the teachers and teacher educators involved in the MOOC Ed will really benefit. Okay, we're just going to do a final round on anything else you'd like to add about computation and misconceptions, and then a final chance to add anything else you'd like to say to the teachers and teacher educators in our audience, and then we'll be wrapped up. So, and if you don't have anything else to say, that's allowed also. So I'll just start with you, Catherine. Is there anything else you'd like to make sure we hear from you today?
Yeah, I mean, I think we have to be very, as we think about the knowledge that teachers should have, the framework that we used in our book was around pedagogical content knowledge, and you know, in the conceptualization of that work that we're drawing on a variety of authors, thinking about knowledge of learners. So what are the misconceptions that we want teachers to know? Knowledge of curriculum. So if we think about the tasks, for example, or the standards, you know, what do teachers need to know about that? We think about assessment or instructional strategies. And so as we move the field forward, thinking about what knowledge in relation to those different components do teachers have to understand. So if I think about the tasks, you know, some examples of things that John's I've seen him do is, you know, having people play around with fractions more than we've had them do that. So I think he talked about this a little bit earlier. Let's say one of the things he did is he wrote 4 problems using the same fractions in them, but you know, in which cases would you use, which computation would you do in these different problems and why, and just having them compare and analyze. Or you know, if you take a fraction with pretty large numbers on it, in terms of the numerator, the denominator, there's this misconception that if I have 738 as my numerator and my denominator is 899, that's a very large fraction because the numerator is large and the denominator is large. So you know, how do we have kids not think about those individual numbers on the top and the bottom, but think about the size of this thing? So if I were to have them think about, well, I wonder what would happen if I take that numerator and I add 1 to the numerator and I also add 1 to the denominator. What's that going to do to this fraction? What's this going to do to the size of the fraction? And so posing those kinds of I wonder what will happen if. You know, so kids do walk into this conversation that when I'm going to multiply 2 fractions, I'm going to get a bigger answer. because, you know, just as Barb talked about or Nancy Max talked about, they're going to draw on that prior experience that they've had with whole numbers. And so, you know, they're going to need to kind of do several problems, get a sense of what's going on here. Let's analyze this. What do you notice? Are the numbers getting bigger? Are they getting smaller? Why is that happening? John writes a lot about generalization. Can we start to have kids generalize about, and how do we design tasks to bring those ideas out? So I think that's really important as we engage kids in really hard conversations and the complexity of this work.
I think some final thoughts that I might have is that I don't think that we can ever underestimate the power of understanding unit, both in terms of whole number and in terms of fractional representations. I'm the series editor for the book that John was referring to, and we have also in that series a pre-K to 2 book that talks about whole number development and number and numeration. And unit pervades all of that. I think without that understanding of unit, that it severely impacts students' ability to access more complex ideas about fractions. The second idea that I would leave with is that the representations are critical in terms of understanding their affordances and their challenges. And investigating, exploring, and playing with those kinds of representations and analyzing what they bring to the table for students' understanding about fractions, and also what they leave students wondering about, are important parts of planning our instruction around fractions. And so I'll leave with those 2 things. And thanks for the opportunity.
I'd agree with a lot with what Barbara says about connecting and attaching meaning to the unit and making sure that we're talking about 2/3 of what. I think we have quite the opportunity with the Common Core, because we're supposed to be developing this deep understanding. If students don't develop the deep understanding of the meaning of fractions initially, they're going to be very confused when they go to operations. They're going to be asking questions similar to what Catherine was saying. You know, what do I do next? You know, what's the rule here? Rather than, and they can't self-monitor. They can't keep track of it. Is what I'm doing, does it make sense? Because they don't have any meaning for fractions. But we found when we're working with our beginning teachers, if we develop a strong understanding of meaning for fractions, they can do all kinds of things with operations, with comparing. Once they have that foundation, they have such a strong base that they can reason from. So now it takes a lot of pressure off myself as the teacher, because they do have all this deep initial understanding. The problem and the challenge that we face is most textbooks that we have don't develop a deep understanding of fractions initially. They go too quickly into how do we get equivalent fractions? How do we compare fractions? What are the procedures for these things? And students learn to initially just count things. Count the total number of parts. Count the number of parts that are shaded. Write this here. Write this there. And that's the initial meaning that they have for fractions, which is not supporting this deeper understanding that we must develop for students. And therefore, they can't self-monitor. So we need to help students understand what these fractions mean. And then a whole new world is opened up to them, and you see many more students be successful with fractions than what we have before.
Great. Catherine, Barbara, John, thank you so much for so generously sharing, I'm sure, just a tiny piece of the wealth of knowledge you each have about this area. I think we have lots of information that will be very valuable to our participants and very useful in the MOOC Ed.